Lightning strikes the Earth about 8 million times a day. And if you've ever looked closely at a photo of one, you'll notice something strange. It never goes in a straight line. It zigzags, branches, and bends like it's searching for something. So why doesn't lightning just take the shortest path down? It starts inside a storm cloud. Ice crystals and hail collide millions of times as they're tossed around by violent updrafts. Every collision transfers a tiny electric charge. Light ice crystals become positively charged and rise to the top of the cloud, while heavier hail becomes negatively charged and sinks toward the bottom. Within minutes, the cloud becomes a giant battery positive charge stacked on top, negative charge pooling at the bottom. The ground below, sensing that negative charge above it, actually becomes positively charged in response. Now you've got two oppositely charged surfaces separated by air that doesn't want to conduct electricity. Here's where the zigzag begins. The cloud sends out an invisible, faint channel of charged air called a stepped leader. It doesn't move smoothly. It advances in short, jagged steps, about 50 yards at a time, pausing between each one. At every pause, it can branch off in multiple directions at once, feeling out whichever path through the air offers the least resistance. Why doesn't it go straight? Because air isn't a uniform material. Tiny pockets of moisture, dust, and uneven charge create a patchwork of paths with different resistance. The stepped leader is constantly choosing the path of least resistance, one short, jagged hop at a time. And that path is almost never a straight line. As the stepped leader nears the ground, something remarkable happens. Objects below trees, buildings, even blades of grass send up their own faint streamers of positive charge, reaching upward to meet it. The moment one of these streamers connects with the descending leader, a complete circuit forms between cloud and ground. Once that circuit connects, a massive surge of current, the return stroke, blasts back up along the exact same jagged path at over 60,000 miles per second. That surge is so bright and so hot, hotter than the surface of the sun, that it's what you actually see as the flash. The zigzag you're looking at is the fossil of the path the scout already carved. And those side branches you sometimes see, those are leftover paths the stepped leader explored but didn't fully connect with the ground. Dead ends that still glow for a fraction of a second when the main surge fires through the primary channel. So that zigzag isn't randomness, and it isn't chaos. It's a record, a literal map of millions of tiny decisions, air molecule by air molecule, all made in the split second before the sky lit up. Next time you see lightning fork across the horizon, you're not just seeing a flash, you're seeing a path being chosen,